So yeah, I'm going to talk about re-architecting for the cloud by disconnecting things, as the title says. And before I go into it, a brief introduction. I'm a lead technologist working at Alma Media, been there for 12 years now. Also, I'm an AWS community builder focusing on developer tooling. And there's also some links and social media handles, so feel free to connect with me after the presentation. And briefly about Alma Media, just to give context for the presentation, because some of the topics will be actually reflecting on things that we have been building at Alma. So we have our roots in 1847 with journalism and media, but since then a long time has of course passed, and these last 10-20 years we've been going to or transforming towards content and digital services. Briefly, just a few key figures. So we talking about transformation to digital services. We have a bit over 100 plus different digital services and applications. So Alma does not create a one single product. Instead, we have a lot of different products. And we operate in 11 European countries and 1,700 employees, of which 40% is outside of Finland. Some of you, especially Finnish people, might recognize some brands here, some of the consumer-facing brands that we have. But besides these, we have a lot of, for example, business-to-business applications. We are building services for the use of banks. And for example, we have systems that pretty much every real estate agent is using here in Finland and things like that. Also, outside Finland, we are market leader in Baltics and Central Eastern Europe in job boards and job-related marketplaces, and also market leader here in Finland in certain categories such as housing and vehicles and different media categories. Maybe a bit more interesting facts about Alma regarding for this kind of audience is our journey with AWS. We started in 2012. Going to AWS, and since then transforming and using AWS more and more. And around 2016, we started using serverless technologies. Of course, we had used things like S3 buckets and things like that. S3 is actually my favorite serverless product in AWS. But in 2016, we started using more and more of these tools like Lambda and API gateways and stuff like that. And since 2018, we started using AWS CDK, late 2018, even though the documentation said that do not use this in production, but we did it we ignored the documentation and used it in production already back then, and we've been pretty happy with the CDK. Actually, yesterday I checked that we have 209 AWS accounts, and the number is always growing because we are bringing different parts of the company to AWS. This talk will not be about CDK because I've been talking quite a lot about CDK in the past, and there are a lot of great presentations about CDK. But I still want to mention it because it is pretty heavily used within our company. And for those of you don't know about CDK, it's a cloud development kit. CDK, a development framework, open source one, but mainly, of course, developed by AWS, which enables you to build your cloud infrastructure using familiar programming languages. For example, TypeScript, JavaScript, Python, Java, .NET, and Go. And we mostly use the TypeScript version, some Python CDK apps and things like that, and maybe even some Go. And also, I think there's some Java, but mostly TypeScript and Python, I would say. But again, I won't go that much into CDK, but I will mention a few things related to CDK throughout this session. And what this session is about, the title is a bit weird one. It could be any of these things or probably many other things. The presentation will go to quite many places, so the topics can jump around a bit, but I hope that in the end of this presentation you will find some common thread across the things I'm talking here. And in essence, I'm talking about this, that we still think of things in we still think of having things in a box. And I'm not talking about, for example, like monoliths versus microservices from a technical point of view. I'm more talking about the mental model that we still have quite often. Instead, what I found is, or what I at least think is that it's more interesting that when we think how the different boxes are connected, or are they like tightly coupled or loosely coupled, or how they are connected. I will go through a few example scenarios, and these are pretty much based on things that we have been building throughout the years. As I said, we've been in AWS since 2012, so we've done a lot of things there already, and we've iterated a lot. So we built something, realized it's not necessarily optimal, and then done something else instead. These example scenarios are based on my own experiences, from the experience of my colleagues, and also from the experience of the community. So, things that I've talked with other people, but I try to showcase them within Alma's context. First example case is this subscription status for paywall content, this kind of a use case. The starting point for the project was that we had a website and an app, and then we had the authentication platform and then subscription system. And somehow we need to make this work. So first we think that, okay, maybe when the website and app will make an update to the subscription system when a user purchases a subscription. So after the payment, subscription will be updated to the subscription system. And when the user tries to access some paywall content, and they do have access to that, the website will actually check the authentication platform and get the subscription status through the JWT claim, and of course verified, etc. And how the authentication platform could know about the subscription status, it would actually query the subscription system. This was the initial idea, but then we realized few problems, both technical and organizational. So the subscription system wasn't originally made for exactly this kind of a scenario there, and there was no internet-facing API to be provided for the authentication platform, and also this website and application here were basically our biggest site, having something like 3 million visitors per week. So the traffic amount was quite high, and it would require a lot of scaling effort for the subscription system. And there was like different data models and things like that. And of course, there were some other like organizational problems that the team building the subscription system was busy with other stuff, etc., etc. So we needed to think about something else. So we kept this part, and instead, the subscription system sends an event. And once we get an event, it goes to an EventBridge event bus, and then Lambda picks it up and puts it in the DynamoDB table. And when the authentication platform needs to get the subscription status, it just queries an API gateway. Probably one or two of these lambdas are unnecessary these days, but this is the architecture that we did back in the day. And the good thing is here that these things scale independently. Of course, there's some eventual consistency, but that works for us in this use case. Another example is a user history service for customer support. So the initial idea was that there's a customer support app, and it needs to get the history of the user. For example, when the user has changed the password or email, or if there's been login problems or something, so they can help the customer when the customer is contacting them. So maybe it could query the authentication platform. Or the customer support, if they could just directly access the authentication platform. But we didn't want to give customer support direct access to the authentication platform, and also integrating these two meant that, or the reason why we didn't integrate these two directly was that, at least at the time, the authentication platform didn't have an integration option available that would have suited our needs, and there was only history available for 30 days, and that would have also meant some integration complexity for the customer support application. Again, we went back to the drawing board, and what we did is that luckily the authentication platform is able to send events because it has support for EventBridge SaaS event buses. And we capture that event using Lambda, which then inserts the event into our ledger database. So we're actually using purpose-built databases here as well. And this has worked pretty well for this use case. And again, there's an API gateway querying the data whenever the customer support application needs it. So again, this kind of a pattern that we're basically separating the reads and write operations, and it has been serving us really well. How many of you, raise your hands if you know what this CQRS, Command Query Pattern, means? Segregation. Good, there's a lot of hands raising up. So just to summarize, if you think about this three-tier application, you have UI, backend, and database. So in traditional approach, you have the same data model in the backend for both the reads and the updates. But in the CQRS pattern, you basically have different models. So you have a query model and command model is about writing or pushing new changes to the database. This is example from Martin Fowler, and it talks more in a context of application, like more traditional application and how you separate data models. But for example, AWS has in their prescriptive documentation this brief article about CQRS pattern and how you apply that to cloud resources. So that is quite useful documentation to check out. And depending on how pedantic you are, you might argue that the two examples I just showcased, they are or are not using the CQRS pattern, but I don't think that's important. The reason why I really like the CQRS pattern is that I like to keep it in mind always, because when applied, at least in a broad sense, when applied to cloud resources, cloud services, it can actually help you a lot when dealing with scaling issues and things like that. Couple other examples. This is a bit random one. About cron services, we had a application service on-premise and a relational database. Of course, this could be the traditional lift and shift operation, just containerize it and run it and migrate the database to RDS or Aurora or something like that. But we took a bit more closer look at what the actual application does and realized it's mostly cron jobs. And when the cron jobs trigger, it will just execute some code path on the server. So instead, what we ended up doing was modernizing the application using Lambda functions that are triggered by scheduled event bridge events. And the nice thing about this is that, well, you make the scheduling more explicit. It's easier to visualize in for example, in your logs and your dashboards, etc., etc. And you also so that you don't need to have to go to SSH into that server and try to parse from the logs that whenever has this cron triggered and what has been done, etc. So having different Lambda functions reacting to different schedules is useful. And also because in this specific case, there are multiple similar kind of situations, but in this specific case, the actual schedules were quite they did not happen that often. Basically, it was like things like once an hour, once a day, a few times a day, or a few times an hour, things like that. Basically, at this point, because it's not that often, we're pretty much operating on the Lambda-free tier here in conceptually. So it's really nice use case for Lambda. Another case, dynamic content delivery. So if you ever work with a media company or company that is providing a lot of content, you probably have some kind of a content delivery thing. And this is a setup that we've done throughout the years many times in various different contexts. And often there's either on-premise or either in AWS Cloud or somewhere, there's some application server that talks to some database. And when a request comes in, the application server will call the database, get some data, and then probably render some content. Maybe it's HTML, sometimes it could be generating JSON files or whatever dynamic content it requires. And oftentimes we have had these like throughout the year situations that the content is relatively stale, so it's dynamic, but it only changes a few times an hour, a few times a minute or something. So of course you can solve this by putting a lot more caching in front of the application servers. For example, you can put CloudFront CDN there, but a common pattern that actually is really nice in these kind of scenarios, if again the content changes based on some schedule or based on some event, is to completely separate the delivery and the rendering process. So we have, again, some Lambda functions triggering, for example, based on a schedule, or it could be whatever event, then rendering the content and storing it into an S3 bucket, and then we just put CloudFront in front of that. So it's just static content. So that is a really nice pattern. Simple but nice and effective. Another interesting thing talking about content rendering is React.js server-side rendering. So we use quite a lot of React. We of course have a lot of different kind of technology stacks, but React.js is quite popular in Alma. And one interesting thing that we do with Lambda is that we are actually doing serverless server-side rendering. So we're using Lambda to actually render the server-side aspect of the web page, and that gets then delivered to the client, and it will hydrate, and then the client-side application will pick it up. But this is really, really nice because, again, you don't have to operate any long-running instances or containers or anything, and you don't need to stress about the scaling that much. Of course, Lambda has its own interesting aspects, but this has worked pretty well. Talking more about serverless, we build a lot of serverless APIs, both GraphQL and so-called RESTful, so HTTP JSON APIs. Pretty much most of the stuff is these RESTful APIs running behind API gateway. So this is quite common diagram. You've probably seen many of these kind of APIs. You probably built these kind of APIs quite a lot. So there's an API gateway, some paths that are triggering Lambda functions that are doing stuff, often accessing the database. So in this example, how you could improve this setup is actually that the Lambda functions here are completely unnecessary. So you could totally remove those. And instead, you could and you should probably directly integrate the API gateway to specific AWS services, because you can integrate API gateway directly. And I think it was probably Jimmy who said that no code is, why write code if you don't have to, or something like that. And I completely agree. The challenge here is that you need to do some VTL templates to sort of define how the request integration and then the response integration looks like, or how the response value will look like. And I'm not necessarily the biggest fan of VTL or the velocity templates, but those are things that you need to do once, and once you get them correct, it just keeps on working. You don't have to, update your dependencies for the Lambda function, monitor the Lambda function, update the runtime or patch security issues or things like that. It just keeps on working once you have done it. So it's a really nice way to integrate different AWS products into API gateway. One bit more specific example is this GDPR data request service that we built and are still building to sort of automate some processes regarding GDPR data requests. And one part of it is this API that actually, when a customer submits this data request ticket, so to speak, there's an API gateway, and that will have some endpoint, and that could trigger a Lambda function. Actually, in this specific case, we're not doing that, but this is a pattern that we've seen many times, and in Alma as well, but I've seen it in many places elsewhere, and I've heard people doing a lot. So what I'm talking about is this monolithic Lambda. So you have API gateway or whatever trigger it is, and then you have a Lambda function behind it. And the Lambda function does a lot of stuff. For example, in this scenario, it's creating a request ticket to, let's say, DynamoDB. It's updating or creating a Jira ticket. It's sending some confirmation email using SES. It's notifying some external systems, sending events to data warehouse, etc. And once it's done, it's returning a response to the client that is calling the API. So try to avoid these monolithic Lambda functions. It's a pain in the butt to create them and manage them, but also it sort of hides the complexity. Instead, think about making the complexity more visible or more explicit. And one way you could approach this is that sort of like transition from there is that you could use step functions. And in this example, the API gateway is actually triggering an express step functions workflow in a synchronous mode. And that will do all that stuff within the workflow that I mentioned, and then it will return the response. So this may be a bit better from the sort of making the complexity visible instead of, and maybe there's potential for less bugs because you don't have that massive Lambda function. So always when you're writing your own code, that is a potential place for bugs to happen. But I would say this is not perfect. Still, this is synchronous request response. So if the client is sending the request, the data request, basically some put operation to request endpoint or something, whatever, it doesn't really need to, there's no reason for the client to wait for the response. So instead, the better way could be that, again, return the response immediately, something like 201 created or something. And the way this is now modified, that we actually added event bridge also in between the step functions and the API gateway. So API gateway is triggering event bridge or sending and doing like a put event operation to event bus event bridge. Event bridge event bus. And once it's done that, it will return to 201 created HTTP response to the client, and the client is happy. Well, I'm not sure if the client's happy because they're making data requests, but anyway. Then the event bridge is sending the events to different targets or different rules, different listeners, and as I think, was it Jimmy or Luke who said that you should have like a rule per target? I think that is a good idea as well. So not bundling different targets to different rules in event bridge. But in this example, we are targeting like step function standard workflow. It could be express or standard, but the point is that now it's also asynchronous. So the steps that need to happen in specific order are done in the step functions workflow. So we are updating the database, creating a ticket into the database. We are updating or creating the ticket to Jira. We are sending some confirmation email to the user. But at the same time, we are also integrating, for example, SNS to notify external systems and also sending events to data warehouse, things like that. So this opens up a lot of possibilities. So definitely recommending on doing this. Amazon actually, I think, has been in their own presentations having the example of like a web, like an e-commerce application where the payment is collected afterwards and the customer is notified if things go okay or not okay. So that is one common example that you can hear or you hear often of this pattern. So we like to do a lot of serverless APIs with direct AWS integrations, and we're using CDK. But also we're big fans of OpenAPI, and with CDK and OpenAPI, it's a bit of a challenge sometimes, and it gets quite annoying because you need to define, if you're defining an API gateway using OpenAPI, you need to have some. You need to have quite a lot of AWS or the API gateway specific sort of fields in the and definitions in the OpenAPI definition, and you can't really use the full power of CDK, and that's why we built this OpenAPI X open source CDK construct. And what this does is this allows you to have an OpenAPI definition and just describe your API there, and then use CDK to actually sort of inject the integrations using your programming language using the strongly typed system and CDK provided interfaces, and from there it will generate the API gateway instance. And if you want to learn more about that, there's a talk about that from last year's CDK day that could be interesting if you're a fan of open API definitions and CDK. Then few words about CloudFront. That is, of course, quite important product, especially for us, because we are doing a lot of content delivery. We are doing a lot of web applications. We're doing a lot of APIs that are somehow exposed to the internet and utilized by our different websites and applications. So let's again think about this React.js server-side rendering step here. So this is pretty much similar that I showed before, but here the React.js rendering process is sort of it's just a generic compute icon there, so it could be a Lambda function, it could be ECS. For example, we're using Lambda functions to render React, we're using ECS to render React, Fargate ECS as well, and then also Beanstalk. So any compute that is doing the React.js server-side render. So, and you have application load balancer in front of that, and then you have a CloudFront, and maybe you have another origin in CloudFront that is the S3 bucket serving static assets. Quite a sort of normal situation. What happens if you have a DDoS and a lot of different clients are starting to sort of requesting your website? Of course, AWS has like specific products that are actually targeted to handle DDoS situations, things like the web application firewall. You could have like rate limits, etc., and prevent bad IPs accessing your service, etc. There's Shield and Shield Advanced and things like that. But one interesting pattern that we've done there is using this like DDoS switch with the React.js. So when a DDoS is detected, we can switch from server-side rendering to just client-side rendering, basically by dropping out the ALB and the compute that is responsible for server-side rendering. And instead, we are just serving the index.html from the S3, and then it will be just client-side rendered React.js. Of course, that will mean a slight impact for all of the users, but it's still better than the whole service going down or something like that. And of course, if you have a DDoS situation, you need to protect your other resources as well. But often the front page or some page in your service is the one that it gets affected. So this is a really nice pattern if you are using React.js server-side rendering. Okay, that is covered. Then more about CloudFront. Let's imagine this situation that we have CloudFront and then some compute. It could be like, or it could be pretty much anything. Let's say it could be like a API gateway and then Lambdas, or it could be ALB and then Fargate or whatever, just some compute behind CloudFront. And you would think that now, okay, CloudFront is added in front of your computer, your application, whatever it does, everything is fine. One thing you should consider is this detour trick that it might be super hard, sometimes impossible, or sometimes it could be easy, but at least theoretically, someone could figure out the domain or the URL of your origin. So if you have, for example, API gateway there or something like that, they could figure it out and start spamming it directly, so skipping the CloudFront totally. And especially in a DDoS situation, that would be super bad thing to happen. So there are a few ways to do it. One thing is to add web application firewall into the mix, and basically how it works that you add the WAF rule to the, for example, if you have an ALB or HTTP, API gateway or something like that, you add a WAF to that origin, and then CloudFront will send some specific like an origin request header, and then the WAF will validate that does the header value match some specific secret value that you defined. And also for that, this is a pattern that is quite common, so we've again created CDK construct for it, so take a look if you're interested. But just to say that these kind of patterns are one of the really good things about CDK that you can solve once and then use everywhere. Again, let's go back to the situation of having a CloudFront, and we've tackled that previous issue, and again, all is fine, or at least we think so. Maybe your application behind the CloudFront is somehow expensive, either like the operations that it does, it could be like performance or actually cost-wise expensive, that you want to optimize the caching. So whenever you have users accessing your service through CloudFront, what actually happens is that because CloudFront is a global service, they have 200 plus or probably 250 plus or something, can't remember, these points of presence around the globe. And if there is a cache hit in the point of presence, then the response will come from that POP location effectively. If there is no cache hit there, so there's a cache miss, then the request will go to a regional edge cache. These regional edge caches, they are, for example, US East 1, EU West 1, EU Central 1, etc., etc. So usually when there's a bigger region, that usually is also a regional edge cache. So if the edge cache has a response, that will then respond to the POP, and also POP will then store that response based on the cache configuration, etc., and then respond to the user. But if the regional edge cache, or a REC, just for short here, if that doesn't have the content, then it will be a cache miss and it will access the origin. But what happens when you have a global audience, each of these users will be accessing your website through different locations globally, and that means the access pattern or the request will traverse to different edge locations, meaning different POPs and different RECs. And it will result in a situation that actually multiple regional edge caches will be requesting the same content from your origin. So there could be, in this example, there's 3 requests coming, but it could be quite a lot more, depending what kind of a setup you have and how many different pages are requested, etc., etc. So this could become expensive. So one thing we have used, and actually, I call this like origin hammering. I'm not sure if that's official term, but I just like to call that origin hammering. But one way to solve this is that I think it was a year or 2 ago, probably 2 years ago, can't remember anymore, they introduced this feature called origin shielding or origin shield. And this is a pretty nice one if, for example, most of your audience comes from a certain region. So let's say your origin, the compute is in the EU West 1, the Ireland region, you could say that, okay, I want to use that as my origin shield. And that will result in a situation that all the traffic will actually, let's say if the US East 1 regional edge cache doesn't have the content that the user is requesting, that will result in a situation that instead of going to the origin directly, the US East REC will actually first query the origin shield REC, so the EU West 1. And if EU West 1 has the response cached, which it most likely has, because every request is going through it, it will then return it from here. And if it doesn't, it goes through the origin through the EU West 1, so the origin shield. So this is really useful pattern if most of your audience comes from different locations, and if you want to protect your compute resources. Of course, if you are a global, like a company that your audience comes from, or you have a global product that your audience comes from different locations around the globe, this won't probably help you, or maybe in some cases, but mostly I think it's useful if your audience comes from a specific region mostly. So that's why, because we are here in the Nordics, I really wanted to mention this one. And again, with CDK, this is super useful to enable. You just configure 2 lines to your CloudFront distribution settings, basically saying true, that it's enabled, and then you set the region that you want to have it as the origin shield region. For example, here is the EU West 1, or you could use the CDK scope to get the region of your, let's say, your origin resources or whatever, but it's just 2 lines. Of course, there's some price component, so you need to think about that as well, but I don't think that's too bad. But again, it always depends on the case, or it depends on your context. Lastly, few things one thing mainly about network connectivity between different VPCs. So here as well, I often see people thinking about networks the old way. I'm not sure if that's really the old way, like VPC peering, is it that old or not? But I'd say a more traditional way. So let's say, actually I'm going one more slide up. Let's say you have multiple VPCs. Here we only have 2, but you could have multiple VPCs and different peering setups between them, or whatever is your setup, but somehow you've combined multiple VPCs, and then you might have like a corporate data center or corporate network also coming through direct connect gateways and things like that, or VPN gateways, or whatever is your setup. But the idea is that you have multiple networks that you're connecting somehow. And that is actually something that at least I have oftentimes experienced, that there is this connectivity between networks. And in the end of the day, the reason, the sort of final result, or the reason why it has been done, or what is actually using that connectivity, is just 1 or 2 services. So there's some service that you are actually exposing to some other VPC or somewhere else. So maybe we shouldn't default to thinking about connecting networks together if in the end of the day we only have 1 or 2 services that we'd like to share to some other VPC, for example. So next time you think about sharing services across the VPCs, maybe instead of peering, for example, use Private Link. Private Link is a few years old service, I think. I'm bad at remembering launch dates of AWS services, so can't say how old, but it's not too old, but maybe a few years anyway. And Private Link is a really nice feature because, or a product, or whatever you want to call it, and maybe it's a feature of VPC or anyway, that you can expose your own services either through load balancing, but also you can expose AWS services. So for example, you could expose API gateways to Private Link or S3 buckets or whatever. But this, I think, is really useful when exposing if you have some service running in the left-hand VPC and you want to expose that specific service or a database or whatever to this VPC on the right-hand side. So you should consider using Private Link, because if we go one slide back to this setup, it can be sort of challenging to keep this secure. Of course, you have the option how you configure these different peerings and gateways. You have your security groups, you have your knuckles, etc., and you could bring your own firewalls and things like that. But again, it's still a lot to think about. That for if you're just exposing few services, you have to think about this whole low-level networking stuff. So again, if you're exposing just 1 or 2 things from one single VPC, use the Private Link. Or maybe in the future, the VPC lattice. I haven't looked into that much, but it seems interesting at least. So in the end, few takeaways. I talked a lot of miscellaneous stuff here, as you probably noticed, went a bit all over the place. But still, my thinking is that often when we approach building stuff in AWS, we have these sort of mental models from past years or something like that, that we just have some system and we put it into the cloud and we sort of build on top of that. But instead, we should be thinking that, okay, maybe we can utilize the different features of the cloud actually better. And also utilizing, I'd say, if you're doing anything web stuff like websites or APIs or stuff like that, CloudFront is really lovely service to use and use it well. Couple last takeaways. For us, CDK has been a crucial tool. So building infrastructure feels like any other programming, and you think in patterns. So in your own code base, when you're defining some CDK application, you can think of these patterns and you can define patterns that are shared within that code base, but also you can create these patterns that you can share externally, either internally in your company or externally as open source, as we have done with few of the CDK constructs. And besides constructs, I think like cloud infrastructure it's really easy to sort of reason about as a pattern. So thinking about patterns in cloud infrastructure, and then it's nice to use CDK to actually implement those patterns. The last one is that for us, infrastructure is our business logic. We are not building applications that run in the cloud. Instead, we are building cloud applications. So this is just something I recommend that you start thinking this way when you're doing stuff in AWS. Because I believe, this is again an opinion, but I firmly believe that this is the best way to get the most benefit out of AWS and cloud in general. So I said the top title was about disconnecting things. Maybe in the end it's disconnecting from your old habits or something like that. And that's it. Thank you.